Hi, this is Ron Cipcic. In this particular segment, we're going to be looking at the duopoly model. This will be the first segment of 3 segments on duopoly. Duopoly is really a special case of oligopoly, and in the case of oligopoly, you have relatively few firms. These firms are interdependent, and these firms often engage in product differentiation. So if you look at the case of duopoly, duopoly is a special case of oligopoly because there's only 2 firms. Duo comes from the Greek word two, and so you have 2 interdependent firms. And we're going to simplify this model. We're going to assume that both of these firms sell a commodity, which means they do not differentiate their product on the basis of non-price characteristics. We're also going to assume that the 2 firms have an equal market share. This will simplify the analysis, though it's not a necessary condition, but we simplify the analysis by assuming that each firm shares the same, has the same market share, at least to begin, and we assume that the firms have the same cost structure, so there's no cost differences. Now, this is really an example of also something called game theory, and game theory is really an analytical tool for understanding how competitors, interdependent competitors, behave with respect to each other. And this game is actually called the prisoner's dilemma. And I'm not going to take the time to explain the history of this model, but this is a case, an example of what we call the prisoner's dilemma. And as the game unfolds, as we work through this duopoly analysis, it'll become more and more clear why we call this a prisoner's dilemma. All right, well, let's dive right in. We want to first of all take a look at the case of competition. So I'm going to go ahead down and move down, and we're going to draw 2 models, and we're going to work with some modeling that has been used in past market types. So I'm going to assume here that we have 2 firms, firm A and firm B. On the left side, it's going to be a picture of either firm A or firm B. Notice the word "or" here, and that indicates we're drawing the firm on the left. On the right, we're going to draw the market, and the market would be firm A and firm B. If you put the 2 firms together, they essentially face the market. Now, just to simplify this, I'm going to draw a reference line across the 2 models. And so we'll just dot a horizontal line across here. Find a point in the middle of this space, and I'm going to put in the minimum point of the ATC curve. The ATC curve is parabolic, so this is ATC, and MC, of course, cuts that ATC curve at its minimum point. And we're going to just leave that as is, come back over here. I want to find a point in the middle of this space. I'm going to draw a downward sloping demand curve through that point, relatively steep, and I'm going to label that with a capital D. Remember, if these are the only 2 firms in the market, then they are going to face the market demand curve together. And then what I'm going to do is I'm going to put a supply curve up through that point, and I will label that with an S. Remember that the supply curve is the MC curve of A plus the MC curve of B. In other words, each of the firm's MC curves constitute the supply curve for the firm, and when we add those 2 MC curves together, we get the market supply curve. So essentially, market supply is a function of the marginal cost curves of the competitors. If there were more than 2 competitors, if there was an MCA, an MCB, and an MCC, the supply curve would be further to the right. If there was only 1 competitor, MCA or MCB, the supply curve would be further to the left. So the MC curve of the firm ends up becoming the supply curve of the firm. If those are summed together, you have the market supply curve. All right, now what we'll do is we'll just tack in some numbers here and assume an equilibrium price over here of 10. So the equilibrium price in this market is 10, and we'll read down and we'll pick up an equilibrium quantity of 9,000. Okay, I'm just making the numbers up. I'll be giving you the numbers and basically telling a story with the numbers. Now, if each firm has an equal market share, then each firm is producing 4,500. All right, so 9,000 is the total market share, total market, and then 4,500 is the market share of each competitor. So we'll come back over here to the left. We're now looking at the firm again. I'm going to draw a horizontal demand curve here. So clean this up a little bit so we can... Now you go, well, why'd you draw a horizontal demand curve for these two firms? I'll explain this. Let me just get this cleaned up a second here. And here we go. And this is going to be labeled DMR. Now you go, well, this looks a lot like the purely competitive model. It does, but there's only two firms. However, remember, we're assuming that the two firms sell a commodity. So essentially they're selling an identical product. For instance, if you were talking about two gas stations. Now these are not two gas stations. But if these were two gas stations, they essentially sell gas. We're assuming the gasoline they sell is identical. Okay? So these two firms sell a product called gadgets, and these gadgets are identical. That's the assumption. Price equals 10. Remember, the market determines the price here because, and let me explain this. If both firms charge 10, then each firm is going to sell what? Is going to sell 4,500. So here is QM. That's where MC equals MR, and that's going to be 4,500. Now I'm assuming here this market only has room for two competitors. There's only enough room in this market for two competitors to essentially break even. If there were three firms, the supply curve would be further to the right, and the price would be lower, and DMR would be below the ATC curve. Okay, and all of the firms would be losing money. So with only two firms in the market, the supply curve is here. Market supply curve is here. The price is 10, and 10 is sufficient to keep both firms afloat. Now, this is economic break-even. If you look here at the point, this point here, this is the economic break-even point. Notice that demand curve is just tangent to that ATC curve. So we're assuming that firm A and firm B are breaking even. The reason they're breaking even is the market can only contain two firms, and those firms just get by. If there was only one firm in the market, the supply curve would be further to the left over here on the right. The price would be higher. That firm would be profitable, but another firm would then want to enter. Okay, so we're assuming that other firms can get in if there is profit. There is no profit, economic profit. This is an economic break-even position, so the market only has room for two firms. Okay? Now notice what would happen here if one of the firms tried to charge more than 10. If one of the firms tried to charge more than 10, it would go from selling all that it sells, 4,500, to selling nothing. Why? Because there's another firm selling exactly the same product. So one firm doesn't have an incentive to charge a price above the other firm. Likewise, one of the firms would not undercut the other firm. Okay, say that firm A tried to charge 8 and tried to pick up all of firm B's customers. Well, the problem with firm A charging 8 is it's below cost. You can see here that 8 is well below the ATC curve, which means firm A would actually be losing money. And so a firm does not have an incentive to undercut another firm in this situation because it would be cutting its price and incurring a loss. Yes, it would pick up all the customers, it would pick up all the other customers, but it would be losing on those sales. And of course the other firm, firm B, would see that firm A cut its price and could match it. So they would both be losing money. So undercutting your competitor makes no sense in this case because your competitor will see it, match it, and you'll both lose. All right, so we see that in the long run this market stabilizes at this point here. This is basically a long run break-even point. Okay, and that's where this is an R here. You know, it's hard to read. I'm doing this on a Saturday morning, and I sometimes forget how to write on Saturdays. I apologize. I am used to working Monday through Friday, so when I work on Saturdays I forget how to write. So back to our regular programming here. This is a long run break even point. Okay? And again, if you remember the purely competitive model, what's going on here? Price equals ATC, ATC equals MC, MC equals MR. Well, at that point, all four curves go through that point. The DMR curve goes through that point. ATC, MC go through that point. So the price is 10. The average total cost is, whoops, sorry about that. Using numbers here. I've got to start thinking. This is Saturday. I can think on a Saturday. I just have to work harder at it. So this is 10, this is 10, this is 10, and this is 10. And this is all true at what? At 4,500. All right? So we can see here that the firm is breaking even. Each firm is breaking even. However, economic break-even still means accounting profit. So the firms stay in business, but they're not earning an above normal profit, which is called an economic profit. Okay? So let's go ahead and do the calculation here under competition. Under competition, both firms break even. That's the moral of the story. And so if we take price minus ATC times Q, we get what? We get total profit looks like my marker's taking the day off as well. And the price is 10. The average total cost is 10. So the average profit is what? 0 times 4,500, which is a total profit of 0. Again, this is economic break-even, not accounting break-even. The accountant would be showing a profit here. For each firm, the firms are just not earning an above normal profit. Okay? Just to get a couple final comments before I move to the next scenario. Notice that, again, the market production is 9,000. Each firm has an equal market share, so each firm produces 4,500. Notice that the firm is optimizing. It's operating where MC equals MR, which means the firm is trying to maximize its profits. Now, in doing so, it is actually losing money. Notice that, or excuse me, breaking even. Breaking even. I misspoke there. Again, it's Saturday. I'm having trouble talking. If it operates anywhere else other than where MC equals MR, it's in a loss position. Notice that at any other output rate, the average total cost is higher than the price. So only where MC equals MR does this firm break even. Any other output rate other than 4,500 would be a loss position for either firm. Okay? Now, let's look at what these two firms might do. These two firms, realizing that when they compete, they simply are bashing each other's head, they're butting heads, and neither firm is earning an economic profit. What these two firms might realize is that if they worked together, if they formed what is called a cartel or a monopoly, they could improve their profit position. Okay? So what I want to show you now is what is called collusion, where two firms work together secretly and form one firm. Now you see collusion. Let me go ahead and write some of this out for you so you have some of this in your notes. So let's go ahead and go to black. We're back to our writing. So this is going to be the case of collusion. And in the case of collusion, let's just define collusion first. Two or more firms, only two in this case, but it could be 3, it could be 4, it could be 5. 2 or more firms work together secretly, and this is going to be secret because it's against the law. These two firms are actually behaving as a monopoly. So collusion is where two or more firms work together secretly to set price and Q. So rather than setting their price and Q independently, they're setting their price and Q jointly. So the case of collusion is where the two firms essentially monopolize. This is monopolization. And this is possible when the number of firms, let's make a note here, this is possible when the number of firms is small. So possible when you have few firms. You know, if you have 1,000 firms, if you're talking about 1,000 corn farmers, you can't possibly, they can't collude. There's too many of them. First of all, you got a coordination issue. Secondly, you have to somehow control these 1,000 firms. They can't talk. They can't tell anyone that they're colluding. Because if the government finds out they're colluding, secretly behaving as a monopoly, then they're breaking the law. They are breaking the law and they're going to get into trouble. So collusion generally, you're only going to see collusion generally when the number of firms is very small and the collusive arrangement, the cartel, can be carefully managed. Okay? Now, when two or more firms collude, this is often called a cartel. So the nickname for this is a cartel. Cartel is the name for this case of collusion. A cartel is basically a monopoly. But you have more than, legally, you have two or more firms doing this. All right, well, let's go ahead and draw this and show you how two firms working together can do significantly better than two firms butting heads and competing. All right, so let's go right into this and let's set up our models again very quickly here. We don't want this to be a 2-hour video. So let's just go ahead and very quickly. So this is going to be dollars. This is going to be Q, dollars, Q. This is going to be firm A or B. This is going to be firm A and B. So this is basically a cartel or a monopoly. Now, these two firms are behaving like a monopoly. Okay, let's put our reference line across. And I'm going to go ahead and dot across our reference line here. We don't want to move the cost curves. We're going to hold the cost curves constant. So come down, there's our ATC curve. Our ATC curve is still touching that dotted line. MC cuts through the minimum point. And come over here, same point over here. The demand curve, same demand curve, no change in demand. I'm holding demand constant. I'm assuming the cost relationship stayed constant, so effectively the supply curve stays constant. I'm not going to call it a supply curve. This is now called an MC curve, but this is MCA. Let me write that again. This is MCA plus MCB. So MCA and MCB have not moved. The MC curve, the cost curves have been held constant. So we're not going to call this a supply curve because we're drawing now the monopoly model. Okay? So this is the old equilibrium point, the old competitive solution is now where MC or supply equals demand. This is still demand here. I am going to clean this up a little bit. We'll make it, so this is still here a price. This equilibrium point is still a price of 10. Okay, and this would still be a quantity of what? This would be a quantity of 4,500. Now, here's the $1,000,000 question. Does a monopoly operate where MC equals demand? The answer is no. Where does a monopoly operate? The monopoly, whoop, try again, haste makes waste. Try again. So the monopoly is going to operate where? Where MR equals MC. And I can't believe I did that. Let's try again. A little technical difficulty here. Mr. Cipcic is trying to hurry and he's messing. There we go. Beautiful. So this is your MR curve. Now I'm going to put it in red so we can distinguish it. Clean up my little mess here. This is 4,500 right here. Okay? Where does the monopoly want to operate? The monopoly wants to operate where MC equals MR. So this firm is going to want to produce at what we've been calling QM, and this is the quantity where the monopolist maximizes profits. What we're going to see is this is going to be 6,000. This number is actually not 4,500. I am got to be careful here. This number is actually, remember, this is actually 9,000. So let's be careful here. The individual market share is 4,500. Okay? All right, now I think we're okay. Now we need to read up. Remember the monopoly model. The monopolist reads up to the demand curve to get the price that allows it to sell 6,000. So what effectively the firm has done, the two firms have combined into one firm, and the new firm wants to sell at 20. This is called price fixing. This is called price fixing. This is where the firm is, two firms are holding their prices artificially high, behaving as one firm, fixing their price artificially high, and we'll see that this improves both revenues and profits. Notice to hold your price artificially high, you have to be able to restrict your output. There's still a demand curve here. Notice this demand curve. There's a demand curve, and if you want to charge 20, you're going to not be able to sell 9,000. You can only sell 6,000. Okay? So basically the way the game works is the two firms are secretly colluding. The two owners have gotten together. They're fixing prices artificially high. And how are they holding that price at 20? They're holding that price at 20 by restricting their output collectively to 6,000. Well, let's go ahead and read 20 across back to the firm. So the price now, each of the firms are now charging 20, and the DMR curve has moved up to here. So this is where DMR is. Okay? Again, the demand curve is horizontal. Each firm must charge 20. If one firm charges less than the other firm, it would pick up all the customers. The other firm would cut its price. But they're colluding. They're working together. So they're going to both charge 20, and there's no incentive for one of the firms to try to charge more than that. That breaks the arrangement. Now, keep in mind that the minimum point of the ATC curve is 4,500. Remember, 4,500 is half of 9,000. Right? So the market sales are 9,000 if the two firms charge 10. Market sales are only 6,000 if the two firms charge 20. So the firms can't be operating at 4,500, and they definitely cannot be operating where MC equals MR. Each firm cannot operate where MC equals MR because that would be more than 4,500, which means they'd be producing more than 9,000. They can't do that. Each firm has to be willing to operate at an output rate well below what it was willing to operate at before. So go to the left of 4,500 and then note 3,000 like I've done. 3,000 is 1/2 of 6,000. Notice that has to be less than 4,500. So each firm must restrict its output, reduce its output rate for this arrangement to work. This is called Q quota. So the two firms establish a quota. The quota is what the cartel agrees to. So there's only two firms in this cartel, two owners, and they've agreed to each produce 3,000. Now notice, if they produce at this output rate, something very interesting happens. I'm going to actually switch to green here. Now let me put in the ATC. The ATC is 16. I'm just making the numbers up. 16 is between 20 and 10. Remember, 10 is still down here. This is 10. So 16, I'm just picking 16 as my number. It's a number between 20 and 10. And notice I have a profit box now. I have a profit box. So each of these firms is now profitable because the price is above its average total cost. What's happened by colluding, there's been no change in cost structure. Cost structure stayed the same. No movement in demand, no movement in supply, MC, no movement on the cost side, the supply side, no movement on the demand side. The only change is the two firms are secretly colluding, restricting their output, holding their price artificially high, and look what happens. The firms go from break even. They go from break even, now they're in a what? They're in a profit position. So price minus ATC times what? Times Q equals what? Equals total profit. So what do we have here? The price is 20 minus average total cost of 16. They're no longer operating at the minimum point of the ATC curve, but no matter. They've moved into a profit position. This actually equals $12,000. So by restricting their output, jacking their price up, the two firms have moved into what? Into a profit position. Now let me show you something here. I want to show you a couple things before I wrap up. I'm going to go back to black. It's easier to see. Move this up a little bit. Let's take a look at the revenue side first. If you take price times quantity, you get total revenue. Okay, so when the price was 10 and the two firms were selling 9,000, total industry revenues were 90,000. This could be 90,000 a week, 90,000 a month, 90,000 a year, whatever it is. When the two firms jacked up their price to 20, their sales dropped to 6,000, right? What happened to their revenues? Their revenues went up to 120,000. Now, they raised their price, their revenues went up. Why? Their buyers must have been what? Relatively price insensitive. If you look at this change, this is a 100% increase in price. If you look at this change, this is a what? This is a 33% decrease. What is this? This is actually a 33% increase. So what happened here? The firms jacked up their price, doubled their price, but their sales was not cut in half. It only dropped 33%. Their revenues increased. This means buyers are what? Buyers are price insensitive. It means the ED must be what? Must be less than 1. Why don't we do it? Just for the fun of it. Just for the fun of it. Let's calculate the ED here. So what's the ED? The ED is what? Q2 minus Q1 I'm just going to get rid of the thousands. I'm going to factor the 1,000 out. So it's 6 minus 9 over 6 plus 9 divided by 10, 20 minus 10, 20 minus 10, right? I'm just going to factor the 10 out. 2 minus 1 over 2 plus 1. So we're calculating, using a midpoint formula, calculating the ED. So what do we get here? We get, that's minus 3 over 15, that's 1/5 in the numerator, and then that's 1/2 in the denominator, or excuse me, 1/3 in the denominator. We can get rid of the negative sign. This is 3/5, this is 0.60. So buyers are what? Relatively price insensitive. So when these firms jack up their price, engage in price fixing, they boost both their revenues and their profits. Let me say that again. When these two firms fix their price above the competitive price, they jack up what? They jack up both their revenues and their profits. Alright, we're going to wrap up here. We've already gone on long enough. Now in the next segment, I'll be talking about why cartels like this are inherently stable. And what you're going to learn is there's only one better place to be than to be in a cartel. It's to be in a cartel and be cheating on your partner. Stay tuned.